Hi, welcome back to another episode of Algebra in Words, the video series. In this video, we're continuing our discussion on quadratic equations. And in previous videos, I told you that there's a number of methods you can use to solve quadratic equations and functions. And one of those ways is to use the quadratic formula. The quadratic formula is the formula that I have written here. Now, of all the different methods, you might be wondering, when is the proper time to use each method? Well, I went over basically, if you can factor and solve, that would be ideal because it's fastest. But sometimes you can't factor and solve. So in that case, you might either do the complete the square method, which I explained last video, or when all else fails, you can default to the quadratic formula. And also, I look at the quadratic formula as like the ultimate default method because when in doubt, or even if you're not in doubt, you can always use the quadratic formula, and the quadratic formula will solve any type of quadratic equation. There's no limitations. If you remember for the complete the square method, there were certain conditions that have to be met for A, but those conditions do not apply in this case. So for example, in this case, A is -3, and that's fine. You can use whatever form and numbers that the terms come in to put in the quadratic formula. The only thing that must be in place is that your equation or function must be in standard form, because the quadratic formula is basically a formula where you plug in values for A, B, and C, and you must have it in standard form so that you can properly know what A, B, and C are to plug in. Now, a quick little aside is if you're wondering, where does the quadratic formula come from? And I'll give you the quick answer, but I'm not going to go through the whole thing. If you started with the standard form, generic form of a quadratic formula, ax squared plus bx plus c, and you put that through the complete the square method to solve for x, long story short, you would arrive at this. And if you notice, if you look at the details, alright, the formula is -b plus or minus the square root of b squared minus 4ac, that's under the radical, and that's all over 2a. As I was always reminded, make sure that this is all over 2a, not just 2a under the radical, it's under everything. Also, take note of this little detail, the plus or minus. And if you remember from the complete the square method, oftentimes you got a plus or minus because you usually get a plus or minus whenever you take the square root of something. And this is a square root, so there's going to be a plus or minus. And that means that there's a likelihood that there could be two answers split up into a positive form and a negative form, where part of it is added and part of it is subtracted, and that could ultimately give you a maximum of 2 solutions. Now, also, just a brief reminder that using the quadratic formula is a way of solving quadratic equations, and solving means finding the x-intercepts. And ultimately, you could plot the x-intercepts in order to fully graph the quadratic equation as a parabola. So anyway, without further ado, let's get started. Now, basically, this is easy because as long as you write down the quadratic formula property, whether you're copying it or ultimately, you probably should memorize it because I don't know if your teacher will give it to you on a test. But either way, all you're doing is plugging in. So you just have to be able to identify A, B, and C and plug in. And from there, simplify. Make sure that you simplify it correctly with the proper order of operations. Again, overall, this is pretty easy, but I am going to make sure that you get a good mix of examples where you can see some of the later steps where it might get a little bit tedious, and I'll make sure that you're exposed to a few different examples. Also, before we start, just a reminder that you can get a maximum of 2 solutions. You could also get 1 solution. You could also get no real solutions, but in that case, with the quadratic formula, you'll notice that you're going to arrive at two solutions that come in the form of complex numbers. And in those cases, they're not real solutions, so they're not really x-intercepts. You can't plot them because they include an imaginary part. So to summarize that, you could get two real solutions, you could get one real solution, or you could also get two imaginary solutions which will come as complex numbers. Okay, so let's get started. I have the formula written, and I have an original equation given. It comes as a function. It's in standard form, so we're able to get started. A is -3, B is -1, and C is 4. So all we're going to do is plug into the formula. So let's do that below, and let's start by writing x equals negative, and since b is -1, that's fine, put -1 in for that, and since it's going to be a negative of a negative, that will ultimately become positive. So -1 plus or minus the square root, and b is -1, and we'll square that and we'll simplify that in the next round. -4, it's always -4, and a is -3, and c is +4. And now we're just going to go back through from the left to the right and just simplify. This should have been negative, so negative of a negative is going to be +1. Plus or minus, let's rewrite the square root again. And actually I noticed I forgot to put it over 2a, so let me pause that and do that. Okay, and over 2, and a is -3. Okay, now let's start back on the left and simplify. So negative and -1 is +1, plus or minus the square root, and -1 squared becomes +1. And then we have -3 times -4, which is -12. Or we could do, so let's do these to get -12. And then -12 times -4 is going to be +48. And that's all over the product of 2 times -3 in the denominator, which is -6. Okay, so let's move on towards the right. And let's rewrite 1 plus or minus. And now under the radical, let's add 1 plus 48, which gives us 49. The square root of 49 over -6. And let's continue to the right. The square root of 49 is 7. Now normally we would say plus or minus 7, but the plus or minus is already built into this. So we just write 7. And don't forget over -6. And now since we have the plus or minus, we have to break this up into a plus and minus. And so let's do the plus up here, where we have 1 plus 7 over -6. 1 plus 7 is 8 over -6. And now there's a common factor of 2 in the top and bottom. So 2 goes into 6 3 times, and into 8 4 times. So one of our solutions is -4/3. And not a big deal, I moved the negative to the top, but you could just apply it to the side. And now let's look at the minus form of this. 1 minus 7 over -6. 1 minus 7 is going to be -6 over -6, and -6 over itself equals 1. So our two solutions from the quadratic formula are -4/3 and 1. And that pretty much concludes that example. There's not much else to say. To summarize, we started with the standard form equation. We substituted a, b, and c into the quadratic formula and simplified as much as possible. And that's what we got. -4/3 and 1. They're the solutions, meaning that they are the x-intercepts. They're real numbers, and we could plot them on the graph, and the parabola would go through those 2 points on the x-axis. So I'm going to pause the video and put up one more example. I put another equation on the board, and I put it up here this time so that we have a little more room to work over here. So again, basically there's not much strategy to it except we're going to plug in. Let's get started. We want to check to make sure our function is in standard form, and it is. So let's start filling in and plugging into the quadratic formula. So let's write x equals, and negative, and what is b? -2. Always plus or minus, then the square root. B is -2, so we'll put that in for b squared minus 4, and multiply that by a, which is 4. And c is -3. All over 2a. And a is once again 4. And now we're just going to go left to right and simplify. So let's come down here, and we have negative of -2, which is +2. We'll write 2 plus or minus, and the square root. -2 squared becomes +4. And now we have, let's do 4 times -3, which is -12, times -4, which becomes +48. And that's over 2 times 4, which is 8. And now let's continue to simplify. Rewrite the 2 plus or minus the radical. And now under the radical, add 4 and 48, and that gives us 52. Over 8. Now let's pause a second, and we want to be focusing on the square root of 52. Now in the last example we did, where we had the square root of 49, that was a perfect square, and we reduced that and took the square root of that to get 7. But you could encounter many cases where the number under the radical is not a perfect square. In that case, you want to reduce it down as much as you can. And I went over reducing radicals in previous videos if you need to look back at those. But in summary, try to factor that radicand into all perfect square factors and any other factors that remain. If there's any perfect square factors, then you can take the square root of them, and they'll come out front of the radical. In this case, the case of the square root of 52, there are no perfect square factors, and it cannot be reduced anymore. So in that case, you're basically done. Could you convert it to a decimal by putting square root of 52 in the calculator? Yes, but usually we don't, because usually the radical form is the most exact, and we usually leave it in radical form, and you should be comfortable in working with and leaving the answers in radical form if possible. Now before we circle the answer, I always want to repeat that you should always look to see if there's a greatest common factor in the numerator to factor out. In this case, there's not. So basically, we're done. And in the case where the radical cannot be reduced or gotten rid of, then it's common that you leave your answer with plus or minus. And keep in mind, that does represent 2 answers. Could you split it up and write it as 2 plus square root of 52 over 8 and 2 minus square root of 52 over 8? You could do that, but normally we just write it in one consolidated way like that. So this is acceptable. So I'm going to pause this video and we're going to look at one more. So I put another problem on the board, and it is 3x squared minus x equals 1. Now, before we get into solving it, I want to just tell you, because I looked at the answer and I chose this problem for a reason. I chose this problem because in the end, we're actually going to get imaginary numbers and a complex, what will become a complex number, and that's why I chose this. So we should expect that in the end. I wanted to make sure that you get some exposure to that way as well. Now, let's look at our given equation. Is it in standard form? In this way, it's not. So we want to convert it, and to do that, we're going to subtract 1 from both sides, which will move it back to the left. And it's going to look like 3x squared minus x minus 1 equals 0. And from there, now we can start by plugging into the quadratic formula. So x equals negative, b is negative 1, plus or minus the square root of, and b is again negative 1 squared, minus 4, a is 3, and c is now negative 1. And that's all over 2a. So write the 2, and a is 3. Okay, so now we're going to, from left to right, just simplify. Negative of negative 1 becomes positive 1. Always plus or minus, and then the radical. And negative 1 squared is positive 1. And now we have 3 times negative 1, which is negative 3, times negative 4, which will become positive 12. And over 2 times 3, which is 6. Okay, so let's continue, and we're going to get 1 plus or minus the square root of 13 over 6. Can we simplify the square root of 13 anymore? No. Now, as I promised you in the beginning of this problem, I thought this was going to turn out to be a complex number with an imaginary, but basically I was not looking at the right problem. But that's fine. This is the answer, so this is just another example. 2 solutions, 1 plus square root of 13 over 6 and 1 minus square root of 13 over 6. But now I'm going to pause it and find one that does come out with an imaginary number at the end. Okay, this one will definitely come out with an imaginary number and a complex number at the end. So to start, notice this is not in standard form. Let's subtract x from both sides, then it will be in standard form. So if we subtract x from both sides and put that in the middle, it's going to be 3x squared minus x plus 2 equals 0, and now we're good to go. Now we'll plug into the quadratic formula. X equals negative b, which is negative 1, plus or minus the square root of b squared, and b is again negative 1. That's squared, minus 4 times a, which is 3, and c, which is 2. And that's all over 2a. So 2 times a, which is 3. And let's simplify going left to right. Negative of negative 1 is positive 1. Plus or minus, negative 1 squared is positive 1. And now we have 3 times 2 is 6, times negative 4 is negative 24. And let's put that over 2 times 3, which is 6. I want to briefly pause and just point something out, because this is going to give us insight into the direction this is going. Let's just look right here. We have 1 and then minus a number that's bigger than 1, 24. We already know just from this point alone that we're going to get a negative under the radical. Now, in most books, they talk about what's called the discriminant. The discriminant has to do with the number under the radical. And although I don't I don't find much significance to the discriminant because the answer comes out in the end anyway. But regardless, it's a real thing. And I just want to take a minute to point out that the discriminant will give you insight into whether there's going to be one solution, no solution, or two imaginary complex solutions. Since this discriminant is going to be negative under the radical, negative under the radical means that we're going to end up with imaginary numbers, meaning two complex number solutions. And by the way, whenever there's imaginary numbers or complex numbers, they always come in pairs. They won't come as one or the other. Alright, so anyway, let's continue. So anyway, the point to me explaining that is we're going to get imaginary numbers, and we can tell that just from those details right now. So 1 plus or minus, and 1 minus 24 is negative 23 over 6. Now, so obviously now we have a negative radicand, negative 23, and we would normally want to look at the negative 23 and see and ask ourselves if that could be simplified anymore. And basically, there's one thing we can do to it. We can break it up into the square root of 23 and the square root of negative 1. And you may know by this point that you can skip that step and just make it I, the square root of 23. But regardless, I'm showing you all the steps. So this can become 1 plus or minus. The square root of negative 1 comes out as I in front of the radical square root of 23. And that's all over 6. We do just want to do a brief check to see if there's a greatest common factor between this 1 and that coefficient, but there's not. If there was, you would factor it out and then see if that factor factors out with the denominator, but in this case it doesn't. So the two solutions are 1 plus or minus I, the square root of 23, over 6. And those are two complex numbers. They're not real, so they can't be graphed. And although we would normally call them x-intercepts, since they're not real and can't graph them, they're not real x-intercepts, so we can't graph them. This still would make a parabola, though. It's just that the parabola it would make would be something like this. That's a rough sketch. Notice that the parabola does not cross the x-axis, which is why there's no real number x-intercepts. But there is a y-intercept, and figure that that's 2. And again, I did a basic sketch. I don't know if it would be here or here, but it's close enough just for general purposes. But anyway, I'm going to pause the video and try to find one more example where we get one solution. Okay, I have one last solution, one last equation. And it is negative x squared plus 4x minus 4. And let's see what happens. It's already in standard form, so let's plug it into the formula. X equals negative, b is 4, b is again 4, and we'll square that, minus 4, a is negative 1, and c is negative 4. And that's all over 2a. 2 goes here, and a is negative 1. Let's go start on the left and simplify. So we bring down the negative 4. Okay, and now 4 squared is 16. Then we have negative 1 times negative 4, which is positive 4. Positive 4 times negative 4 becomes negative 16. And that's all over 2 times negative 1, which is negative 2. If we continue to simplify, we get negative 4 plus or minus. And what is 16 minus 16? It's 0. And it's still over negative 2. Now a quick pause, and when we're talking about the discriminant, as I did in the last example, where we're analyzing just the number under the radical, when we can see that the value under the radical is 0, that tells us that we're going to get one solution. Let's continue on and see why that is. Okay, so rewrite the negative 4, but the square root of 0 is 0. And that's over negative 2. So when something's plus or minus 0, you just leave that off because you normally don't write that. So therefore, you're just left with negative 4 over negative 2, and negative 4 over negative 2 reduces to 2. And in that case, that's the only solution. If we did a basic sketch of this quadratic, okay, our x-intercept is 2, so we could plot that here. Our y-intercept is negative 4. Plot that here. And look at A to tell whether it opens upward or downward. And it's negative A, so we know it opens downward, which makes sense because now it'll go through like this. And that's a basic sketch. So that pretty much concludes this video on the quadratic formula. There's not that much to know except for that's the formula. Make sure that you copy it correctly, and you might need to memorize it. You always start with a standard form equation so that you can properly extract the A, B, and C, and you plug in and simplify, and as long as you do that properly, you'll get your answers. So that's all for this video, and in the next video, we're going to be looking at quadratic inequalities. So I hope you join me in the next video.